Hello everyone, welcome back to my channel. I am Junaid and today we are going to be discussing about force exerted by jet on stationary inclined flat plate. So this jet is coming from this direction. We can show it like this. So as the jet is coming from this direction and the plate is inclined, it is not vertical. In the previous case, it was vertical like this, right? It was vertical. The plate, you can see this plate, it was vertical like this. But now we don't have a vertical plate. You can see we discussed about this in the previous class. If anyone missed that by any chance, you can watch that, and that will help you to understand this better. Flat plate is basically inclined, but what is the degree, right? The inclination angle is basically here mentioned here, it is theta. Okay, so theta is the inclination angle, okay, with the axis of the direction of the flow of the jet, I can say. So we know that it will this plate will give a normal reaction, right? And the reaction is basically always uh, normal, right? I can say like this, it always has a 90-degree angle. So afterwards what I can do is see, this Fn is basically the normal reaction force, I can say. Okay, and as this is v sin theta, how this v sin theta is coming? So we have any force, right? We have any force, suppose F. Okay, and if we want to further divide it into component, like a horizontal component and a vertical component, right? So if I can say that this is my Fx, so this horizontal component of this force F is going to be, if the angle is with Fx, I can say it is F cos theta, and Fy, what is going to be the vertical component? Fy is basically, we just know that this is going to be F sin theta. So this is the easy way to remember that with the component we want to figure out, like if the angle is with that component, you always consider cos, and with the component you want to figure out, if there is no like angle, if there is no alpha or no angle, you can write sine. So for example, I can show it like this, just for those who may have, like, missed this thing. If this theta is here, right, if F is here, if this theta is here, the angle of inclination is with this, then I can say this Fy is F cos theta, and this is going to be F x, and this is going to be F sin theta, right? This v, you can see over here, this v is in this direction, right? If I want to draw that here, I can draw it like this v is in this direction, right? And the inclined plane is, this is the inclined flat plate, right? So this v is here, so I can say that it can have two components. Like if I divide them into further two components, so there will be two components. This component is, I can say, vy, right? I can say this component is vy, and this is angle is with this, so this is going to be Vx. So Vx is basically V cos theta, and this Vy is basically V sin theta. So from here we can get this V sin theta. Okay, from here we are getting this V sin theta because here we already have V cos theta, right? Okay, so now I'm going to erase this so that uh, it becomes a little bit easy for you, right? Even if you want to capture a screenshot or so. Okay, so this is the way. Okay, so this is the inclined plate, and the inclination angle is theta with the jet, with the direction of the jet. Okay, so as this v sin theta is there, so now you can find the force. See, this v sin theta is the component of the velocity which is acting in the direction normal to the inclined flat plate, right? This Fn I'm talking about. So this is basically the force, and this is basically the velocity that is causing the force, right? So how to like convert this velocity into the force, right? You are right, using the impulse momentum equation, or the second law of Newton, right? So how do you write that equation? You write it like that, that F is equal to, we know that ma, right? Then you write it like that m into dv over dt. Dv is the change in velocity, I can say. This change in velocity, if it is like this, that initial velocity minus final velocity, then you are finding out the force exerted on the inclined plate by the jet. And if you are figuring out final velocity minus initial velocity, then you are actually calculating the force exerted on the jet by the inclined plate. So basically there are two cases, and I have discussed about it in the previous class also, right? So yeah, if you haven't watched that, please consider watching that also. It will clear your all doubts. Okay, then I can write it like this, m over dt. Okay, m over dt and dv, right? Then I can write m over dt is basically the mass flow rate, right? M over dt, if I am going to be talking about this, right, you know that m over dt is mass flow rate. And mass flow rate, what is the unit of mass flow rate? Mass flow rate is basically kg per second, I can say in SI units. Okay, kg per second. So I can write m by dt as rho into q. I have shown that how we can write that in the previous lecture. And this rho q, you can again write rho a v. Here a is the cross-sectional area of this jet, and this v is the velocity. You can see over here this velocity. Okay, this velocity. Okay, so you can further write it like this. So m dt I can directly write rho a v and dv. Okay, so here I can write rho a v and dv is basically the initial velocity minus final velocity, isn't it? So yeah, like this we can like derive the value of f. So if I am talking about the value of fn, then how I am going to write that? So it is this thing exactly we have studied in the past, in the previous class, the previous lecture. So now I am going to be showing you that how directly I am writing this rho av into initial velocity minus final velocity. So now I will not consider this parts. Okay, I will skip and I will directly jump from here to here in the later classes. Okay, so yeah, let's go and see what we have got here. So yeah, let a jet of water coming out from the nozzle striking an inclined flat plate as shown in this figure to your right. So v is the velocity of jet in the direction of x, already told. Theta is the angle between the jet and the plate. So this theta I am referring this theta. Okay, I am referring this theta, and this theta is made with the jet. Okay, with the direction of the jet, I can say also. A is the small is the area of cross section of the jet, and so the mass of water per second striking the plate. So rho av. See, I have already showed you that how rho av is coming. So this is basically mass m dt. M dt equal to, at first you can write rho q and then you can write rho a v. If you see the dimension, if you do a dimensional analysis, you can see that left hand side and right hand side will be equal, right? Plate is smooth. Okay, if we consider that the plate has like ideally there is no if we consider that there is no roughness, but still there are some surface roughness, but we are considering that the plate is smooth and it is assumed there is no loss of the energy due to the impact of the jet. Okay, this is an ideal condition, but actually it is not true, right? So yeah, of course there is some surface roughness, there will be some loss of the energy, but we are not taking that into our consideration. Then the jet will move over the flat plate of after striking with a velocity equal to the initial velocity. So let us find the force exerted by the jet on the plate in the direction normal to the plane. So now we are talking about this Fn. So this Fn, so we are talking about the force exerted by the jet. So of course this force exerted by the jet, because there is some velocity, there will be some force, and that force will be calculated using the impulse momentum equation or the Newton's second law. So force exerted by the jet on the plate in the direction normal to the plane. So we are considering this direction, the direction of Fn, okay, which is normal to the plane, right? So we have represented this by Fn. So Fn is how you are going to measure Fn. Previously, I have shown you that the force will be measured using mass of jet striking per second. So basically, this is basically the mass flow rate into initial velocity minus the final velocity. But as this is Fn, so of course the velocity will be in the direction of Fn. So according to Newton's second law, and the initial velocity and the final velocity will be in the direction of Fn, which is the normal direction of the inclined plate, right? So yeah, and afterwards we find that so mass of jet striking per second, the mass flow rate into initial velocity of jet before striking in the direction of n, and minus final velocity of jet after striking in the direction of n, right? So now what we are going to get is, so see, this mass of jet striking per second is rho av, right? And the initial velocity of jet before striking in the direction of n, what is the initial velocity? From here I can find that the direction of the jet in the x direction is basically v, but the component of this velocity in the direction of normal to that inclined plate is not v, right? Yeah, of course. So that is basically a component of this velocity, and how we have got that component, I've already talked about that, right? So that component is v sine theta. So this v sine theta is the velocity in the direction of that Fn. So I can say that this is the initial velocity of jet before striking in the direction of n, that is v sine theta, and the final velocity we are considering is 0, right? So initial velocity is v sin theta, which is like before striking, and after striking we are considering that as 0 in this direction only, but there will be some certain velocity in this direction, right? Then we can get we can just simplify the calculation, and we can get rho a v square sin theta. So we already now know the value of fn, but components of this fn in x direction and in the like y direction. So you can see two arrows here, so I have drawn them. So this fn is having a velocity component in this direction, which is I can say fx, and this will be fy. So here you can see this angle, right? So this angle is what? So as this angle is theta, I can say that this angle is also theta, right? As this angle is theta, so I can say this angle is also theta. So it means that this angle will be 90 minus theta, as already mentioned there, right? Because this whole is 90 degree. So 90 minus theta. So what is the value of fy? I can say very easily. See, fy will be fn into sine and angle. Angle is 90 minus theta. So I'm eventually getting fn sin 90 minus theta is basically cos theta. And what is the value of fx? So from here I can say that the value of fx is going to be equal to the value of fn into cos 90 minus theta. So fn into cos 90 minus theta is basically meaning fn sin theta, right? So let's see. So this is the exact same picture, and so we are having two components, fx, which is the component of fn in the direction of the flow, I can say, and let us do the calculation. Then fx is going to be equal to fn cos 90 minus theta. I already showed you in this slide. The fx equal to fx equal to here fx equal to fn cos 90 minus theta. See, and so cos 90 minus theta is basically what? Sin theta, and then sin theta I am writing and I am putting the value of fn. Fn is rho a v square sin theta, and this sin theta is already there, so I am getting rho a v square sin square theta. And then if we want to find the value of fy, so let us remember again that what was fy. Fy, if I have a component here, this fy is going to be fn into sin 90 minus theta, right? So this is going to be fn cos theta. So this is fn cos theta. So now we are going to be dealing with that. Let us see. Yeah, so fn sin 90 minus theta, then we are getting fn cos theta. So what is the value of fn? Fn is rho a v square, and rho a v square sin theta. So rho a v square sin theta is the value of fn, and cos theta is already there, so we are getting rho a v square sin theta into cos theta. So yeah, that is it. So we have got two components of that normal force to the inclined plate. I want to make one thing clear here, okay? So as I have already showed you, this velocity v, okay? So this velocity v is the velocity of the jet, right? So this is the jet velocity. So this velocity after striking here, okay, as it has like the two components, one is v sin theta and another component is v cos theta. So if I want to show it like that, so if this is v, and if this is the inclination angle theta, then I can say that this is v sin theta, and this is basically v cos theta. But one question can be there in your mind, that if this is v cos theta, it means I'm saying that this is v cos theta, na? And if this is v cos theta, then why this is v? So it means that it is in this v cos theta and this v. So I can say that the resultant outcome, I can say the resultant efflux jet velocity can be written as v plus v cos theta, right? I can say it like this, na? Like as both of them are like vector quantities, and this v cos theta is the value, and it has a direction in this direction, I can say. So you can make a point, you can make a question that this v cos theta and this v should be added to get the resultant velocity, because both of them are vector quantities, and we know how to add two vector quantities. You cannot simply add like two vector quantities like you add in the scalar quantities, like you add 3 plus 2 is equal to 5, but two vector, if you want to add a plus b, you cannot add you cannot add direct, it is not directly a plus b. You know what is that? This is basically root over a square plus b square plus 2ab, and of course cos angle between the two vectors. We say it like this. We get this from the resultant equation, like parallelogram theory from vector. We get it like that. So you can make a question. This is a valid ask. I want to clarify you this, that this v cos theta this v cos theta or this v sin theta, right? This v sin theta is basically the initial velocity in the direction n, right? In the normal direction, I can say in the normal direction. So this is the normal direction, right? In the normal direction, the initial velocity in the normal direction to the plate, to the flat plate before striking the plate. And after striking here, we are assuming that this velocity is 0. And this v here, why this is v, so you don't have to add them. Why? Because this v cos theta is the initial velocity component, right? So this is initially we consider it, but it is not considered at the final outcome, so you don't add them. Okay, this is first point. And second point is this, that we have already said, see, I can show you. So in this slide, so see, this plate is smooth, we have assumed, and it is assumed that there is no loss of energy. So conservation of energy principle, or you can say no loss of energy principle. Due to that, we are assuming that after striking, after having the impact with the flat plate, the jet will move over the plate with the velocity equal to the initial velocity. So this v it is an assumption. Okay, but if there is, like, some surface roughness on this, on here, then of course this v will have some other velocity, may or may not be equal to this v, this initial v. Okay, so this was one clarification I wanted to add. Thank you so much for listening till the end.